Welcome back. Today's notes are on pedigrees. We are still doing genetics of pedigree, kind of like the dog food. Actually, it's not the dog food, but the dog food does come, the name does come from what a pedigree is, which is like a family history. And so I think with the dog food, they probably want you to think about like, oh, your dog has a really strong family line or something. I don't really know. But that's what we're talking about. We're talking about family trees, and pedigree is kind of like a genetic characteristic map. So that's what we're going to talk about today. So since we're talking about our family genetics and history, I thought I'd give you some backstory. I used to be a wheat farmer, and I kept getting these like really strange headaches, but I went to the doctor and he said it was just migraines. So anyway, let's keep going. Just before we start, I thought you should know that I also made this note template. I made that for you in a Word document, so you can print that out and write on it. Or if you don't want to do that, you can just copy down everything that I am writing, okay? So let's get going. Pedigree notes. So what a pedigree is basically just a genetic, here we go, come on. A genetic characteristic map that we can use to trace a certain characteristic or certain trait back through your family, okay? And so some of you have probably seen this before, but I just want to give you some of the basics of this. So you see the map down below, and wherever there's a square, that is a male, and wherever there is a circle, that is a female. And then you also see that some of them are shaded and some are not shaded. So the shaded ones, like this, like these, right? Those are the ones that we are going to say that have the trait that we are looking for, or that we are tracing back through your family. So that would be a male right there who has the trait. And then if there's a open square or blank, that means they do not have the trait that we are tracing back through the family. Okay, so just some basics on this. When there's a line between two people, they have children together. So the children that they have is signified by a line that goes down from there, and then out, and then down to the top of either a circle or a square. If it goes down to the top of either a circle or square, that means these are the children of the people above them, okay? So here this family had 3 kids, 1 boy, 2 boys, 1 girl, and then this boy marries this girl right here, and then they have 2 girls here, okay? So this part isn't in the note document that I gave you. I'm just kind of going through this to show you real quick, so don't worry about writing this stuff down. Okay, let's do some relationships. So who would this person be right here, number 4? Who is this person to number 2? Think about that real quick. That is the positive union 2, sister-in-law, okay? And then who is, person number 1 down here, who is person number 2 to person number 1? Person number 2 is person number 1's aunt, right? So this would be the uncle for person number 1. All right, I think you get how this works. All right. Oh, these numbers on the side here, this just indicates generation. They're not on all of them, but like this is generation 1, generation 2, generation 3. And then these numbers are just pointing like, oh, that's generation 2, person 1, just so we can identify them. All right, let's get on to an actual problem, because that's pretty much as complicated as it is. It's pretty easy to understand. All right, example problem number 1. So the first thing that we want to do when we're solving these, okay? So basically what we're going to do is we're going to figure out what are all of their genotypes, okay? So is it this? Is it this? Is it this? We're going to figure out their genotypes, okay? So the first thing that we need to do is we have to discover whether or not it is a dominant or recessive trait. And we can do that by looking at this, because we know that the ones that are shaded have the trait, okay? So here, I'm gonna write some notes down here, okay? So you don't have to, well, you could write these. So let's do this. Let's just make a key, and we're just gonna guess if the trait is dominant or recessive. So let's say we are gonna guess that the trait is recessive, right? So that means, and so this is no trait. This is not the trait. So that means that anyone who has the trait, which you know is shaded, these people have to be r, right? So what we're going to do is we're going to label them. So this is what you should be doing. Label those guys. All right. Well, that means you know that the people who are not shaded here and all throughout here, they have to be or big R, right? So that's what those people are going to be, right? So let's see if this works. Before we write it in this box over here, let's see if it actually works. Okay, so can we make this person big R? Let's see, does this work? So if I make this person big R, and this person's little r, that is not going to work, because look, their Punnett square, if we make a Punnett square, all of their kids are going to be big R. And so that would mean this is big R, this is big R, and that works for these two because they are empty, but this one is little r. So we know that this person cannot be big R. So I'm actually going to erase that. Sorry. Oh, wait, what happened? Okay. So let me get rid of that stuff. So let's do. Okay, so we're back to this. So this person then has to be big R. And if we do this Punnett square, then this is good, because now we have basically a 50-50 chance of getting little r or big R. So that's what these kids have to be right there. All right, they cannot be anything else. Make sure you understand that. That can't be anything else. All right, number 4, or person 4 here. Okay, so we know that these guys have a kid who's little r. So can this person be big R? No, they cannot be big R. Just to prove it, let's do a Punnett square to see if that person is big R. Then all of these are going to be no trait. Okay, so this cannot work like this. X. So in fact, I'm going to erase these, and we're going to make this person also big R. And so that means this person down here, they could be two things: big R, or big R. Make sure you can. How did I get this? Well, just a Punnett square between this and this. You guys should know that pattern by now. All right, so now we can fill out all the questions here. So the key, we were correct in guessing that this is no trait, and that little r was the trait, right? That was our key. And so, in fact, I'm going to say it was recessive, okay? The trait is recessive, so it's little r. Find out all genotypes. Okay, you don't have to do anything there. Just put a check. If you did it, we did it. What is the genotype of person 3, generation 3, person 2, generation 3, person 2? Oh, well, we have 2 options. Which one is it more likely, though? Ooh, okay. If you do this Punnett square, you're going to figure out that this is, nope. This is 50% chance, and this is only a 25% chance. Okay, so it's more likely this one, but you can write both. All right. Is this a sex-linked trait? Oh, this is a good question. This is going back to last week. So A sex-linked trait means, or if it's an X-linked trait in particular, if it's X-linked, then it would be more likely to occur in boys, right? Because boys have only one X chromosome. And so here we see that 2 boys are affected and 1 girl is affected. Well, that's not overwhelming evidence to say that more boys are affected. That's almost just equal. So we are going to say, no, this is not a sex-linked trait because we have 2 boys, 1 girl. If it were like 5 boys and 1 girl or 6 boys and 1 girl, something crazy like that, then that might mean that. All right, let's go on to example problem 2. This is all we got for the notes. Okay, so here is a bigger one. Again, if you did not print out this worksheet, I expect you to draw out these pedigrees in your notes. Okay, that's what I'm going to be looking for. So we're going to do the same thing as last time here for the first step. The key, is it recessive or dominant? So I'm going to do the same guess. So I'm going to guess that it's recessive just because it's kind of easy. So trait. So remember what that means is that anyone who has the trait we know is shaded, and that means they have to have a little r, little r. So if they're shaded, they have a little r, little r. Let's do this. Just watch for now, because as it turns out, is this one correct? No, this is not correct. So hopefully once you try this, you can see that this doesn't work. You have 2 parents here who have little r, but what would their Punnett score get them? They would get them all kids who are all little r, and this one is not little r, and this one is not little r. So this does not work. Okay, so I'm gonna keep that in our notes, but I'm just gonna do this. This does not work. Okay, and I'm gonna erase the rest of it. So, all right. Now let's try this then. Big R is trait. So now we're saying the trait is dominant, right? It's not recessive. Oops, okay. So what this means here is, actually this is kind of easy too. Well, we can do big R, or big R, little r, is shaded now. That's what this means, right? Because people who are shaded have the trait. So now it's either this or this that is shaded. However, it also means this. This is another thing that's easy for us to do because there's only one option. So it also means that little r is now blank. Okay, so I can go through and label all of these little r, but instead of being shaded like the last problem, now I'll just write inside here. Now they're all blank, the non-shaded ones. And now we can go about filling out these. And kind of just like the last problem, this person here is going to have the ability to be this or this, but you should see pretty quickly that this one does not work, right? It does not work because if we have this big R, and little r, then that means all of the kids would be big R, and that's clearly not true, okay? Because down here, this person, or sorry, these two kids are little r. So we can't have two big R's in parent 1 here. So, sorry, this is getting messy. I'm going to erase this and write what it is. So this parent has to be big R, little r, okay? So that means that this person is going to be big R, little r, right? It can't be big R, because this parent does not have a big R. Big R, little r, big R, little r. All right, cool. So that's good for that family. Now, person number 2 here marries this person, and they have kids. And so, again, can we do big R? Let's see. No, we cannot, because we have 2 little r kids. So, erase. This person is big R, little r. And then they will have these kids here. So, but that means, right, if we do that Punnett square again, which you probably already know the pattern. I'm sorry, I'm doing this just wasting your time. This person can be big R, little r, big R, big R, or big R, little r, big R, big R. Okay. All right, we filled it out. That wasn't too bad. So our key, this one over here is correct. We said BAM trait. So it's dominant. This is a dominant trait. Recessive. I'm going to circle this dominant. That's what we figured out. Fill it out. Good. What is the genotype of person labeled 1 on the pedigree? Big R, little r. What is the person genotype of the person labeled 2 on the pedigree? 2 is big R, little r as well. Yep. All right, guys. So these can be tough, but you just gotta puzzle it out. Okay, it's really just logic. It's just logic games. So the more you practice, the better you'll get. Okay, so I'll have a couple example problems, or sorry, I'll have a couple problems for you guys to do. Just refer back to this for help, or let me know if you got any questions. All right, bye.